NASA plans to establish a base on the Moon before sending humans to Mars. This base would shorten the process of reaching Mars. SpaceX founder Elon Musk is determined to win the race to Mars. Meanwhile, European and Russian space agencies also discuss sending humans to Mars. However, the harsh atmosphere on Mars poses significant challenges for human survival, as oxygen, a vital resource, is absent there. NASA has devised a method to produce oxygen on Mars, but why can't the method used on the International Space Station, ISS, work there? Welcome back to another episode from the Time Voyager. The desire to settle humans on Mars is driven by scientific exploration and space curiosity. Additionally, there's a sense of urgency stemming from fears of potential disasters on Earth, such as climate change, which could threaten human existence, similar to the extinction of dinosaurs 65 million years ago. This fear motivates the push for Mars colonization, suggesting that someone will inevitably become the Neil Armstrong of Mars. Elon Musk initially aimed to colonize Mars by 2026, but this has been postponed to 2029. On the other hand, NASA plans to land humans on Mars by 2030. The real question isn't who will reach Mars first but how humans will survive once they are there. Mars shares some similarities with Earth, such as the length of a Martian day, only 39 minutes longer than an Earth day, seasonal changes, and polar ice caps. However, the lack of oxygen is a significant barrier to human habitation. To understand how oxygen can be produced on Mars, we need to examine the oxygen and water generation systems used on the ISS. The ISS has two systems, the Water Recovery System, WRS, and the Oxygen Generation System, OGS. The WRS collects water from human waste, sweat, and humidity, purifies it, and makes it drinkable. This system saves about 98% of the water, minimizing waste. The OGS extracts oxygen from water through a process called electrolysis, where an electric current splits water into oxygen and hydrogen gases. While oxygen is used for breathing, hydrogen, a highly flammable gas, is combined with carbon dioxide in another system to produce water and methane gas, the latter being expelled into space. However, this system is dependent on periodic resupply missions from Earth, which is not feasible for Mars due to its distance and cost. Transporting just 1 liter of water to the ISS costs over $10,000. This highlights the need for a system that can produce oxygen using resources available on Mars. In 2021, NASA's Perseverance rover carried an experimental device called MOXIE, Mars Oxygen In-Situ Resource Utilization Experiment. Unlike the ISS, which relies on water resupply, MOXIE extracts oxygen from Mars' atmosphere, which consists of 95% carbon dioxide. The device compresses the carbon dioxide and heats it to 800 degrees Celsius, separating it into oxygen and carbon monoxide. The process is carefully controlled to prevent the formation of carbon deposits, which could damage the equipment. So far, MOXIE has produced only 122 grams of oxygen, enough for a person to survive for 35 hours. Scaling up this system to support a larger human presence would require a bigger version of MOXIE and a significant power source, which presents a major challenge. Researchers are exploring a future technology that can break down carbon dioxide molecules at lower temperatures by inducing vibrations, separating oxygen molecules without the need for extreme heat. This technology has been tested in laboratories but is not feasible on Earth due to high atmospheric pressure and temperature. Mars' atmosphere, however, is ideal for this experiment. The goal is to develop a self-sustaining system that can generate oxygen on Mars using local resources, without reliance on Earth. The ISS, only 400 kilometers from Earth, can be resupplied or evacuated if necessary. However, On Mars, which is 225 million kilometers away, there will be no option for resupply or quick evacuation if the oxygen generation system fails. In conclusion, the challenge lies in creating an efficient, reliable system that can produce sufficient oxygen on Mars. This endeavor is crucial for the future of human colonization on Mars. Thank you for watching this episode from Jam TV. Please like, share, and leave your comments. We'll see you in the next exciting video.